I say today we discuss in series. I want to explain it in look series, but specifically geometric. Again, series. So series is one important part in Calculus 2. However, in pre-calculus, we study one specific, important, and relatively easy geometric series. Okay, what is that? The problem is, suppose that you have this situation. So you are adding 2 plus 2 plus 2 plus 2 plus infinity 2. This is obviously increasing forever, no? And this is equal infinity. When this situation happens, this is called the series is divergent. This is a technical word. It's the action, diverges. The series diverges because, you know, blow out to infinity. However, there are one series that is no diverge, but some people make a noise. Immediately detecting who make a noise. Sebastian, no? Sebastian, you make a noise. No more noise, Sebastian. Okay. Okay, so what means the word series? Series means, guys, okay, you are doing infinity summation. So summation, supposed to the k equal 1, pero to infinity sum, infinity term of the one hypothetic sequence. And the idea is, if this is infinity, divergent. But sometimes happens case no infinity is one specific number. Around 1/2, 2, 3, and this is called convergent. Let me explain this because it's too weird. It's weird because you know you adding infinity element. The answer, professor, is no infinity. So let me explain. Suppose this is an elementary example to understand this. 1 plus 1/2 plus 1/4 plus 1/8 and continue forever in this regular to infinity. Pam, 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 pam. And this is the series. By the way, geometric, I want to explain it, but not now. I want to try to solve this problem using intuition idea. Intuition. Suppose one segment. No, like that. Suppose one segment. All right, let me see. Okay, there you go. Suppose one segment line like that. I don't know. Okay, don't worry for this. And this segment is starting 0 and ending exactly, I don't know. Entonces you add the first guy que es 1. And suppose que 1 is here. Suppose. 1. It's the first. Plus the second, que es 1/2. Well, 1/2 is this segment. This is, I don't know, suppose que this is 1/2. And 1 plus 1/2 is 1.5 or 3/2. Yes, this. Okay. The part que highlight in cyan color is the part is so far the partial sum, accumulate. Like that. Now 1/4. 1/4 is a half of the half, approximately this 1/4. So you see any element that you incorporate to the series is small, and this is not increasing to infinity. It's obvious. 1/8 is the next guy. It's the half of the half. See, this is 1/4, this is 1/8. And so far, the community idea is we have we have the partial sum. Suppose partial sum 1 is 1. That's the first. Partial sum 2 is 1 plus 1 half. It's 3 half, no? 1.5 in decimal. No, try. Entonces F3 is 1 plus 1 half plus 1 over 4, no? I did that part. I did part, this is 3 half plus 1 over 4. Behind it, the LCD is 4. So we have 6 plus 1 is 7 over 4. Let me try to understand much better where come from or what number converges. Yes, possible converges. I want to express this partial sum like a decimal. Okay, entonces es, bueno, 3 over 2 es obvio que es 1.5. And 3 half es 1.5. Plus 1 over 4 que es, perdón, I make a mistake here, no? This is 4 divided by 2 is 2. 2 times 3 is 6. And I 1.5 plus 0.5, no? 0.25. Es 1.75. 1.75. Que es equivalent to 7 over 4. Let me try to verify my calculator. Of course, no problema. Now, x4, okay, I don't finish here, I don't know why. Okay, it's 1 over 8 plus is, well, 1 plus 1 half plus 1 over 4 plus 1 over 8. So you, for example, are doing, this is 7 over 4, that part, plus 1 over 8, and CD is 8, entonces 8 divided by 4 is 2 times 14, plus 1 is 15 over 8. 15 over 8, no approximate because it's you put in a calculator, no, 15 divided by 8 is 2 point, 15, so 15, 15 divided by 8 is 1 point, oh, you good, 1.875. This is in fraction, this is in decimal. Entonces, do you understand, or you try to predict what number converges, what is that number, or no? When you include x to the 5th power, x to the 6th power, x to the 7th power, and also x to the infinity, because it's a series, it's a one number that normally is called a capital S. You predict this or no? Somebody help me to predict this value. Remember, you are in infinity, pero it's smaller, entonces do not increasing too much. Entonces now, the interpretation is que 1 increases to 1.5, 1.5 increases to 175, 175 increases to 1.875, and so on. So what do you believe que es when you add in infinity? Go to infinity or no? Okay, the answer is converge or diverge? Remember, divergence is a technical name used in the mathematicians, divergence to seek one series infinity, no? And this is no infinity, it's a number. Suppose, I don't know, a number. Do you, are you recording? Yes, I am recording, No idea, guys. No idea. Okay, let me make easy. We need to make a decision, 50-50. Is convergent or divergent? Remember, we are adding infinity element, infinity number. The problem is that this is smaller, like this is sketch. Therefore, I am confused, you know, see, I adding a big number plus another big number plus another big number, obviously it diverges. But in this case, I have doubt. Okay? Entonces, try to help me. Converging or diverging? Who people believe que es converging? Come on. Who people believe que es diverging? 50-50. No opinion. Sofía, Natalie, Giselle, Nav, Emily T, Silvana, Sergio Medina, que always help me. Sergio, try to help me. Desiree, and another guys, José T, Cristian, okay, diverge. Giselle dice que es diverge. Nav dice que es diverge. Okay, diverge. Giselle diverge. One more opinion. Sergio, what do you think? Desiree dice diverge. Okay. Sergio dice que diverge. Guys, you are wrong. You are totally wrong. It's converge. It's obvious. It's obvious it converge. I want to prove mathematically, of course. We are talking about intuition. It's obvious. So you continue adding a half of the half of the half of the half. The final number is 2. This final number is 2. It's obvious or no? No, it's confusing, right? Okay. Let me try to prove mathematically. Get 2. In this example, no, in another, you see after I bring another example. Okay, what is the idea behind this? Well, the idea is you take that formula. The partial sum S sub n is the first one multiplication by 1 minus Rm raised to the n power 1 minus R. And I want to investigate, see the series converging or diverging, and I propose one idea. I propose that you try to investigate what happened with the S sub n when the n approaches to infinity. In other words, we are doing infinity summation. And to compute this, you don't know exactly what is the meaning of this word limited, but it's intuition. Suppose que es a huge number, million, trillion. I propose you separate this in 2 pieces. So we compute the limit when the n approaches to infinity. This is the symbolic way in mathematics. I promise in calculus you see the limit idea. Don't worry too much for the idea. The idea is intuition. Minus a limit. So I separate this expression in 2 parts. When the n approaches to infinity of the a1 Rn to the n part, this part, divided by 1 minus. Well, that part is constant. That part is constant, do not depending on n. Therefore, the answer is this. That part no. The part depending the m. Entonces, what happened? What's going on? If the common ratio is a number bigger than 1, suppose 2, 3, 4, 5, and you have 2 to the m, suppose 2, r equal to, and you suppose que n is infinity, it's obvious que that number raised to infinity is infinity, because it's 2 times 2 times 2 times 2 infinity. However, if the common ratio is n between 0 and 1, not including 1 and not including 0. Entonces, for example, one hypothetical number to understand this, you take in the middle of this is 1/2. 1/2 raised to the n power is equivalent to say 1 to the n power divided by 2 to the n power, no? And you know that 1 is a magic number, and when you raise to the n power, the answer is 1. But this no. This is similar to this, but in the denominator. Therefore, this is like 1 over infinity, que es obvio que es 0. because you divide 1 divided by infinity, que infinity is no number, pero ese symbol que indica que es a huge number. If you divide 1 divided by a huge number, es obvio que the quotient is small, 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 small. So under this consideration, que the common ratio is fraction less than 1, therefore that part is 0. And this is the formula to compute the infinity summation in one series when the common ratio is a fraction less than 1. Actually, to generalize most this is absolute value are less than 1. Under this condition, if this condition is valid, therefore the summation is this. And this is convergent. Otherwise, no. Otherwise, diverge. So we come back to our problem at the beginning. At the beginning, I am not sure 100% see this series geometry or no. Remember, I copy again at the beginning. 1 plus 1/2 plus 1/4 plus 1/8 plus infinity. Bam, 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 bam. This continues forever to infinity. Okay. Entonces, to investigate si es geometry or no, you find the common ratio. 1/2 divided by 1 is 1/2. 1/4 divided by 1/2 is 1/4 times reciprocal of this, 2/4, que es 1/2. Wow, fantastic. Entonces I propose you divide 1/8 divided by 1/2, 1/2. And the common ratio is 1/2. And the common ratio satisfies perfectly this condition because it's 1/2 and 1/2 is less than 1. Therefore, the formula to compute the summation of the series, que es infinity element, is you take the first guy and you divide it by 1 minus r. Who is the first guy? 1. Divided by 1 minus r. Who's r? The common ratio, 1/2. Okay, 1 over something, 1 minus 1/2 is 1/2. And reciprocal 1/2 is 2. And the number is 2. Look at that. Exactly we predict. Do you see or no? Do you understand or no? Ow. Do you understand or no? You matching now the intuition idea with the mathematical formulas? Or no? No? Confusing. Oh, converge, yeah, of course, absolutely converge, yes. I don't know who are you because you have used a nickname. Okay. Before I bring now a lot of examples to illustrate very well this idea, right? Sound weird, pero es possible. So this is the classical idea in the series. So what is the fantastic conclusion? When in Cal 2, when you study Cal 2, we study a lot of series. Series is a summation. Okay, we start in 1, and 2, and 3. It doesn't matter. It's the number that we start is not important, but continue forever to infinity. This is serious. So I promise that the teacher can explain calculus 2, explain different technique to prove si this is convergent or no, diverge. However, in pre-calculus, we anticipate something. We anticipate if you realize that this series is geometric and the common ratio absolute value is less than 1. Why absolute value? Because it could be positive or negative. It's the same. Now the series is convergent and convergent to that value. S equal A1 divided by 1 minus 1. Otherwise, see the common ratio is greater than or equal to 1, absolutely diverge. And diverge means que this summation is infinite. Cool? Do you understand now? I promise que the teacher in Calc 2 explain not only geometry, but you anticipate. Geometric is, in my opinion, the easy case of the convergent or divergent. Clear? Let's see another example. Suppose this 2 plus 4 over 3 plus a over 9 plus bam, 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 and it's continued forever to infinity. See, this is finite, not infinity, so you put plus something here, but no. This is dot, dot, dot. So you suppose that this continues forever. This is equivalent to say one series gets summation from k equal 1 to infinity of the 1a sub n term. By the way, I want to find the expression here of the explicit. So I want in this example determine two things. What is the summation notation que condensing this series in one piece? Number one, and number two, analyze convergent or divergent. In the case que convergent, determine at what value converge. Okay? So first of all, you check it if it's geometric or no. You divide 4 over 3 divided by 2. So you divide any element divided by previous. It's 4 over 3 multiplication reciprocal, no? 1/2. You eliminate here, you simplify, reduce it to 2. Okay, let me verification and one more. Suppose a over 9 divided by 4 over 3. Okay, a over 9, I copy exactly the same, therefore I convert division problem to multiplication, flip it, the second fraction. It's 3 over 4. And do simplification a little bit, divided by 4, 1, divided by 4, 2, divided by 3, 1, divided by 3, 3, it's 2/3 again. Wow, fantastic. It's geometry, yes it is. Geometric, series, and by the way, the common ratio is 2/3. So now, under this conclusion, what do you think? Convergent or divergent? Help me. I need your help. Convergent or divergent? Come on. Answer me. Convergent. Emily D. C. Convergent. Why, Emily D? What is the reason? Because convergent, she said, Emily say, convergent, professor. And the reason is because it doesn't go to infinity. But no, this is the, I know, cause and effect. You told me about the effect. Yes, why? Cause and effect. What is the cause to converge? What is the reason? Can you see? Because the common ratio is equal to the, is that one. Perfect. Sergio Medina say, because professor, this is less than 1. This is the reason. And this reason implies this conclusion. Converge. At what value converge? Okay, the formula. What is the formula, professor? This formula, A1 divided by 1 minus R. And the story. Who is A1? A1 is the first, get 2. Divided by something, 1 minus R. Who is R? 2/3. Okay, cool. Now copy that. R is easy. Is 2 divided by, this is in my mind, this is 3/2, no? Because 1 3/2, it will say 3 minus 2, 1/3. And now division, you copy 2, exactly the same, and time, and flip it up, 3 over 1. And 6, convert it to 6. Okay, cool. Cool. Enough, say it's cool. But I have surprise for you. I have surprise for you to see the beauty of that one. Look. Suppose I want to discuss in this decimal number, que you know is repeating decimal number, repeated. Suppose 0.6, and this symbol indicates repeat, repeated decimal. That is equivalent to say that this number is 0.66666 infinity 6. Okay, my question is, this number is rational or irrational? What do you think? Tell me. Question. This number is rational or irrational? What do you think? Help me to understand this. Opinion. Any opinion? Nobody know? Rational, irrational. Do you remember the definition? Rational or irrational? No? Nobody remember that? Okay. Rational, I think. Yes. It's rational. You are right. Why? Because rational is any number that we can express it. For example, what is rational? Rational is a whole number, of course. It's a whole number. And also is fractions. Also. So it's a number that we can write like a, I don't know, 3/4. Like a fraction. And irrational, you number say irrational is equivalent to say crazy number. No? Irrational. Is the decimal que have infinity decimal places. One classical example is pi. It's 3.14, 15, 9. I don't remember any other digit, but it's infinity. But the problem is, okay, in this example, when another example, this is rational radical 2, radical 3, is a typical irrational number. We never can express like a fraction. No. And the reason is because we have infinity non-repeated decimal. Never repeat. So we cannot discover any pattern. Therefore, when you arrange this, never give me a fraction. However, we have also infinity now, but repeated. But not necessarily equal. I suppose when another example is 0.45 repeated, okay, 0.45, 45, 45, infinity 45. This is rational. And we can get a fraction associated with this number. Okay? So now, to study this idea using the series, geometry series, let me try to do my best. Let me try. Suppose we come back to the famous 0.6. This is n fraction. Okay, this is 0.6 plus 0.06, no? Plus 0.006. N fraction to see much better, at least for me, is 6/10 plus 6/100 plus 6/1000. No? Make sense of this? Plus, and this is a zero, continue correct. Well, I have no idea. It's a geometric series? Yes, I suppose that yes. It's geometric series. And where's the common ratio, the famous common ratio? You divide this divided by this divided by this, and this divided by this. Take 6 divided by 100. divided by 6 over 10. 6 divided by 100 times, flip it up, 10 over 6. Oh, 6 is cancelled. 1 0 is cancelled. It's 1 over 10. And you get the same answer when you are doing the second division, this divided by this. This is the common ratio. The common ratio is 1 over 10. My question again is, this series is convergent or no? Convergent to one number or no? Is convergent to one number or no? Or divergent? What do you think? 50-50, convergent, divergent. Tell me, what do you think? Are you there? Convergent. Sergio dice convergent. Why, Sergio? What is the reason? Because something happened. Because a 1 over 10 get less than 1. Beautiful. This is the reason gets converged. Cool. Let me erase that part. Convergent, not divergent. And what value convergent? Okay, and the formula? The formula is A1 divided by 1 minus 1. Who is A1? A1 is the first guy. Get this. It's 6 over 10. It's much better, at least for me, it's easier. Reduce the lowest term is 3 over 5. Because it's an even number, no? 3 over 5 divided by 1 minus 1 over 10. Get the common ratio. Okay, cool. It's a 3 over 5 divided by, this is 10 over 10, no? This one is, I consider 10 over 10. 10 minus 1 is 9 over 10. Okay, now 3/5, you copy. And you flip it out, it's 10 over 9. And simplification. Divided by 3, 1, divided by 3, 3. Divided by 5, 1, divided by 5, 2. It's 2/3. It's 2/3. The answer of this is 2/3. And this is no secret. This is no secret. You know, you remember. And your knowledge, you have the arithmetic. Now I encourage you, you have calculator right now. Put in your elementary calculator, put 2 divided by 3. And you see you have 0.66666. And of course, the display of the calculator truncate and round off the last digit like it's 7. But actually it's not like that. It's continue forever to infinity. 2/3. Cool? Do you understand the idea? But I need your help to understand another little bit more confusing, or at least for me. What do you think about 0.9 repeated? 0.9 repeated. It's crazy. 0.9 is 0.9999 infinity 9. Using intuition, what do you think? What do you suppose is this answer? So you write not like that. Infinity repeated. No. I try to find the rational number associated with this idea. 0.9 repeated. Intuition. Come on, use intuition. No? You don't understand this? You predict the answer of this or not? No, like that. I want the answer like this. In one fraction, no? Something divided by something, no? Like a fraction, no? Is rational. You predict or no? No prediction. Okay, let me try to repeat again this idea. This is easy. It's 9 over 10 plus 9 over 100 plus 9 over 1000 plus It's infinity, no? Entonces now, the common ratio You divide this, divide by this. It's 9 over 100 divided by 9 over 10. Okay, I copy the numerator exactly the same, and the denominator flip it. 9 cancel, and cancel out 1 0 is 1 over 10. Oh, it's exactly the same of this combination. But the thing changed in the formula to say convergent. It's expecting, no, convergence. But the thing is that A1 is again is 9 over 8, 9 over 10, sorry. So the formula is S is equal A1 divided by 1 minus R. A1 is 9 over 10. And 1 minus 1 over 10, no? Que es the common ratio, look at that. Entonces we have 9 over 10, and this is 10 over 10, que es equivalent to 1, minus 1 over 10, no? And 10 minus 1 is 9. So 9 over 10 divided by itself is over the 1. And make sense this one. Pues, you know, a decimal que contain infinity 9 is very, very close to 1. Yes or no? Si es infinity 9, no es close, es equal 1. Okay? Sound weird? Sound weird or no? No, for me not sound weird. Look, let me try to understand in another point of view. Si you believe que 0.6 repeated is 2/3, you accept this idea. If you divide by 2 both sides, 0.3 repeated is 1/3. Yes or no? Now, if you multiply by 3, 0.3 repeated times 3 is 0.9 repeated. If you multiply by 3 here, 3 cancel out with the answer is 1. Yes or no? 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 Yes. Okay, thus I would like to appreciate so much the students que are doing one extra credit problem, que is suppose 0.45 repeated. And the question is rational or irrational? Yes or no? Is rational or irrational? It's obvious that the answer is rational, no? Why? When you have repeated, but this repetition imply one specific partner, 6, 6, 6, 6, 3, 3, 3, 9, 9, 9, 45, 45, 45, 23, 23, 23. This is rational. Si es completely crazy, no partner is irrational. Okay, so the answer is yes, it's rational, but what is the value of this fraction? What is the fraction? I don't know, 98 divided by 234. I need to investigate this number. This is extra credit, 5 point extra for the test number 4 reading test. So you explain me in detail this idea. What is the value of the rational number 0.45? Repeat it. So 0.45, 45, 45. Entonces now, no repeat it here. It's 45, 45, 45, infinity 45. No? When you finish this, your verification, you answer, and the calculator, you put in the calculator, suppose that the answer is, I don't know, 44 divided by 85. Suppose that this is the answer. You put in the calculator, press enter, and verify that we have infinity 45. Cool? 5 point extra for the test number 4. Reading test. Okay? Okay. I left that. You enjoy this. Okay, now we go now to a new section. Very interesting, very easy, que es the mathematical induction. Mathematical induction. Mathematical induction. Okay. In what part you apply mathematical induction? Well, because you have to prove some formulas, no? For example, in the summation notation, I give you a lot of formula. You don't know very well where come from this formula, no? Entonces now, we use mathematical induction that I want to explain in a few seconds. You get the idea. Okay? So what is the idea? Suppose motivation example to understand what is mathematical induction. Motivation example to illustrate the application of the mathematical induction. Suppose we have the following idea. Suppose I have odd numbers. The first odd number, you know, is 1. Okay. The second is 3. If you add 1 plus 3, is 4. And 1 is just 1. And you adding 1 plus 3 plus 5 is 9, right? Entonces you see, wow, this look like weird. Entonces now this is equivalent to say 1 square, 2 square, 3 square. ¿Es a coincidence or is a fact? I have no idea. Let me try. You suppose now 1 plus 3 plus 5 plus 7. This is 12. This is 4. This is 16. And 16 is 4 squared. Wow. So this is n equal 1. This is statement. N equal 2. This is statement. N equal 3. This is statement. N equal 4. This is statement. N equal 5. I have no idea. N 1 plus 3 plus 5 plus 7 plus 9. No? Get the next odd number. No, this is, I did a bar, is 16. 16 plus 9, 25. And 25 is 5 to the square. Wow. You see, how you write this, I don't know. I need to prove infinity possibility. No, I cannot. I need to create one strategy to prove this without infinity possibility. Well, the thing I tried is, let me try to write this like an equation, this big problem to equation. I basically 1 plus 2, 1 plus 3, sorry, plus 5, plus 7, plus 9, plus bam, plus odd numbers, always odd numbers, is equal the natural number is m squared. You see, an odd number, how you represent odd numbers mathematically? Well, it's obvious that the natural number is m, the even number is the natural, the even number is 2m, multiplication by 2, no, because it's even, and the odd number is 2m minus 1 or plus 1, depending, no, dependency. Suppose you start in 1, n equal 1, so the explicit formula to generate odd number is 2m minus 1. Why? Let me try to understand. Suppose n equal 1. 2 minus 1 is what? Cool. Suppose n equal 2. 2 times 2 is 4. Minus 1 is 3. 3. 1. 3. Suppose n equal 4. 4 not 3. 3 times 2 is 6. Minus 1 is 5. Okay? Do you understand this idea? So the thing I try to prove is this. So I visualize one problem, Okay, I cannot solve them, but I believe it's true. However, I have no the mathematical tools to prove that. Okay, I want to explain that. That's the idea behind the mathematical induction principle. Mathematical induction principle. Mathematical induction principle. Entonces let me write mathematical induction principle. Induction principle. Principle. Okay, what is that? Well, the word induction indicates us that this working like one detective. Okay, one detective of the FBI have some clue of the problem and integrate different clue and infer a conclusion. Okay, induction is try to find conclusion from the particular example. It's exactly the thing that we are doing here. We have some particular example 5. Suppose que I continue 6, 7, entonces now and the n equal 30 fail. Entonces this equation is completely false. Okay. Suppose que no, suppose que yes. Entonces, what is the idea behind this? You are doing 2 steps. Step 1, que is the basic step. The basic step is to prove that the statement 1 is true. What means that? Statement 1 is when the n is equal 1. So you suppose n equal 1 is true. Suppose que no, que it's not true. So you try for n equal 2 and not true, and n equal 3, entonces it's true. You need to find the smaller number to be true the statement. In this case, at the beginning was true, because in the first one, look, 1 equal 1. Okay, 1 is 1 squared. At the beginning, statement 1 is at n equal 1 was true. Nice. We finished the step 1, for the basic step. And now after that, so in the majority of the example, this statement is true for the first one, but not always. That is the reason I explained. Maybe 2, 3, 4. In one moment you say it's true, and this continues forever. Suppose that 3 is true, and 4 is true, and 5 is true, and so on. And we have another step, that is the inductive step. It's the most important.
What
the hell? Guys, turn the microphone off. Okay. The microphone off. Okay. The inductive test. Let me try the page. You assume. This is a complicated part. You assume. S sub k is true. Who is S sub k? Well, suppose k 1, 2, 3, 4, 5. This is M, but k is one guy in the middle, k. In the position, I don't know, 20, 21. Suppose que in one arbitrary position, que I call k, this statement is true. So, because I cannot continue. Suppose que S1 is true, S2 is true, S3 is true, true, but I assume that this is true. So now, if under this assumption, you can show, imply sk plus 1, que es the next guy here. K plus 1 means next. Suppose que es 21, the next is 22. It's also true. Entonces now, this continue forever. Look, suppose like a piece of domino. Piece of domino. Like that. Entonces this is, you push the piece of domino and hit the other piece and fell down, down, down. So you assume in one hypothetical position. Okay, this is true, and fell down, and K plus 1 fell down. This continues forever, like that. Then a mathematical idea is, suppose que S sub K is equal to, this is formal mathematical, and you prove somehow, okay, I want to explain your moment, that S sub K imply S sub K plus 1 is true. That means that S sub K plus 1 is always true. This sounds a little bit similar, but no. This is the implication that this is true and imply that it's true. Okay, this implies that this is true. So you prove, for example, see x1 is true, and you prove that x1 implies that x2 is true, then x2 is true. And this process continues. Si S2 implies that S3 is true, S3 is true, and it's continuous forever. This is the principle. This is the principle. Entonces, what is the fantastic conclusion? The fantastic conclusion is the S sub M, okay, either way you want to call it, true for all natural numbers. Belong to the natural number. Okay. Okay. Entonces, let's move on to the motivation example, no? Okay, I believe using the intuition is important in mathematics to anticipate the thing before you prove formally. I want to prove formally this idea: 1 plus 3 plus 5 plus 7 plus 9 plus bam 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 any odd number, okay, represent like a 2n minus 1 is equal to n squared. I want to prove that using mathematical induction principle. And remember, basic step. Let me try to prove that S1 is true or not. How you prove this? Well, X1 is the first guy, X1. I'm plugging in here. So 1 is equal, and the right hand side, you put 1 squared. It's obviously true because 1 is equal 1. Boom. Now, you assume the inductive step. You assume S sub K is completely arbitrary in the middle here, K. You assume this. Okay, how you represent this idea? Well, easy. You copy exactly the same equation. 1 plus 3 plus 5 plus 7 plus 9 plus bam 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 bam, but you put here no M, you put K, you put 2K minus 1 is equal to K. Suppose it's true. So it's the same equation, why not? And this I assume is true. True, remember this is true. So you will be able to prove that the next is K plus 1 is also true. This process repeats forever. How you manipulate this? You copy exactly the same 1 plus 3 plus 5 plus 7 log 9 plus, you copy this guy, gets 2k minus 1. And you include what's the next of this. Let me try to understand what's the next. Mentally, I replace k for k plus 1. So you copy k plus 1 in the place of k replace here. Entonces 2k plus 2 minus 1. It's 2k plus 1. 2k plus 1. Okay. I include one new. Okay, it's the next. It's easy. Determine the general expression, the explicit expression, when you replace k for k plus 1, and you get 2k plus 1. No problem. In the right hand side, we're doing exactly the same. No k squared is k plus 1 squared. Cool? Do you follow me so far? We don't finish. This is the last moment, important moment. Now, so you assume okay, this part is true, is equal k squared plus 2k plus 1. It's that part, okay, I remove the parentheses because not necessary. And you FOIL this, k plus 1 times itself is k squared plus 1k plus another k plus 1. And when you combine that term, this is k squared plus 2k plus 1. And this expression is twin brothers with this expression. The infinity proof. Cool? Cool? Do you understand? Confusing? Bueno, opinion, any opinion. This laptop, my laptop, don't let me. Sorry. And let me try to see, I don't know, the chat maybe. Do you see or no? A ver the chat. Desiree dice yes. No, this is at the beginning. Now actually cool. Naf say it's cool. Okay, Naf. Okay, let's practice. At least 2 more examples of the mathematical induction. Okay, and we are ready to move into another topic. Suppose one easy. Suppose this. You remember that when you study summation, we studied that formulas. Look, 1 plus 2 plus 3 plus to the m is the sum of the first natural number is equal to n plus 1 divided by 2. Do you remember that formula? You remember or no? Let's do it. Now I want to prove this using mathematical induction. Remember, statement 1 to be true. Statement 1 is under the assumption that n is equal to 1. And you take the first guy, is this. Not always happen, but it's 1. Should be equal, plugging in 1 here, 1 plus 1 divided by 2. It's over the 1 plus 1 is 2, 2 and 2 is cancelled, 1 equal. True. Okay. See, this situation doesn't happen in the first. You try n equal 2, n equal 3. In one moment it's true. And this is the basis step. Not necessarily the basis step is coincident 100% with the 1. But in the majority of cases, yes. Okay, now I want to go to the important, the most interesting part is the inductive step. Okay, you assume S sub k is true. Remember, S sub k is totally hypothetical number in the middle here. Okay. Entonces it's easy because you copy exactly the same equation, but not m anymore, you put k. And you suppose okay, this equation, boom, is good. It's true. Yeah, I want to generate the next one, que es plus 1. I don't know if it's true or false. But it's easy, you copy exactly the same. You copy k, and you copy one more. Okay, k plus 1. Okay. In the right hand side, you replace k for k plus 1. This is k plus 1. This k is no k anymore, it's k plus 1. And this is k plus 1 anymore, it's k plus 2. Because one more. So you replace here for k plus 1, another k, of course. K plus 1. And 1 plus 1 is 2. Divided by 2. Okay. Almost. I finish. But remember the assumption was okay, that part is equal to this. K plus 1 over 2 plus k plus 1 should be equal. I prove somehow using algebra okay, this is the identity. This is the same or no? I don't know. Okay, now it's relatively easy. You find the least common denominator to condensing these two guys in one only fraction. LCD is 2. You have k plus 1, and you have 2 times k plus 1. Make sense, right? And you temporarily you ignore this right hand side. I'm working algebraically in the left hand side. You apply maybe, well, no. I can see clear like a water. Look at that. Okay, k plus 1 is common factor. You factor out k plus 1, and you have k plus 2. Okay, this k is this k, this 2 is this 2, divided by 2. Wow. And this is exactly the same of this. Don't. Another student says, no, professor, I don't see this. Okay, no problem. No problem. Anyway. Look, some students say, no, I don't like this way. I don't see this way. Okay, I understand. No problem. You apply distributive property. And you multiply k squared plus k. Distributive property. And distributive property here is 2k plus 2 divided by 2. Okay, and now we combine later. This is 3k plus 2 divided by 2. Cool. I finish the left hand side. I move it on the right hand side. In the right hand side, you apply FOIL here. K times k, k squared. K times 2k, 2k. 1 times k, 1k. And 1 times 2 is 2. And we combine later again. We have k squared plus 3k because 2k 1 plus 1k is 3k plus 2k. This is the right hand side equal the left hand side. This is the identity. That means that this is working for any k from 1 to infinity. Therefore, you prove mathematically using mathematical induction. You get the idea of sound weird. Sound weird, eh? Weird or confusing? Come on, I want to hear opinion. I promise, guys. In the test, you see only one question like that, okay? No, not too much. But okay. Again, we go over again in the review package. Okay. Okay, I believe que es con esto. Do you want to do one more of this or no? What do you think? One more is needed or no? No?
Okay, we can do it one more.
Okay. You say, okay. I expect. My intuition says I expect this answer. Okay, no problem. Let me complicate a little bit. Suppose this. I want to prove mathematically this idea and summation notation. Is m plus 1 to m plus 1 divided by 6. Do you remember that formula that we used in the last class? This is the, suppose you expand this. I write in this way because I want to practice a little bit the summation notation, but no. S1, 1 square, no? S1, 2 square, 3 square, plus plus m square. Okay. Suppose I omit this part because I don't feel comfortable with this part. No problem. Okay, exactly the same. Basic step. X1. I don't know if it's true. X1 is the first one, this one. And the left hand side and the right hand side, plugging in 1 here. This is 1 multiplication. 1 plus 1 is 2 multiplication. This is 1 times 2 is 2, no? 3, no? 3 divided by 6. Oh, it's 6 divided by 6, that one. Cool, it's true. It's true. Suppose you don't get through here, you continue. 2, 3, 4, 5. Suppose never you get through to say now, definitely this is not true. Right? Now let's move on to the important part, inductive step. Guys, this is the organization that I want to see in the test. Basic step, inductive. You assume S sub k is true. How you write that? Easy. You copy. 1 square plus 2 square plus 3 square plus plus now no m anymore, k square is equal k plus 1 2k plus 1 divided by 6. So basically the only thing you should do is copy the same original equation, but you replace n for k, because k represents one intermediate number. Okay? Okay, you assume it's true. Because I want to try to find the expression for the next case, x sub k plus 1. So you bring down everything, no problem, exactly the same. But you include this, and include one extra, it's k plus 1 squared. And the left hand side. And the right hand side, you replace k for k plus 1. Be careful, algebra. This is k plus 1, so it's logical. This is k plus 1 is k plus 2. But this is not logical. This is, let me try to do my best. The extra additional algebra here to replace k plus 1 plus 1. Distribute the property 2k plus 1 plus 2, sorry. Plus 2 plus 1. Oh, it's 2k plus 3. Oh, cool. This is 2k plus 3 divided by 6. Do you see this idea or no? Do you follow me? So the first step inside the inductive step is just replace m for k. And now in the next is include one extra, k plus 1. But in the left and in the right. Cool. Now, you know that part is equal to this. K plus 1 to k plus 1 divided by 6 plus k plus 1 squared should be equal this. They need to prove this. There are no rule. Using algebra, FOIL, distributive property, least common denominator or something. In my paper, I did end that way. Look, let me show you. I condensed this and this in one common denominator que is 6. I have then k plus 1, 2k minus plus 1, sorry, plus 6 times k plus 1 squared. And for a moment, I don't touch that one. I manipulate left hand side and right hand side in your moment. Maybe I'm doing something or not. Okay, so now different strategy, different way. Don't hesitate to do everything you consider good. For example, I can see, wow, k plus 1 is common factor. I factor out k plus 1, sorry. You see k plus 1 is common factor here and here, no? At least one. So we have here k, only k, multiplication by 2k plus 1, plus 6 multiplication by k plus 1, something like that. Everyone follow me so far or no? Okay, this is not the unique way to manipulate this. You're using your imagination, algebra, that you know very well of the intermediate. Now, distributing. K plus 1. We have here, we have 2k squared distributed. This time this, and this time this. Plus k. Plus 6k, look, distributed property again, plus 6. Divided by 6. Wow, to no problem. K plus 1, we combine like term, 2k squared, plus 7k plus 6. Okay, cool. Divided by 6. I don't know if this is equal or no. The right hand side, because so far we have this situation. So I see, wow. I propose you one smart idea. One smart idea is, suppose can you keep k plus 1 in the top here. Or not here, here, one line before. So this k plus 1 is this. I copy, just copy. And you foil these two binomials. And 6 stays, of course, alive. This is k times 2k, 2k squared. And k times 3, 3k. And 2 times 4k. And this is 6. Wow. And when you combine like term, this and this together is 7. Boom. Same equation. They are identical, unbelievable, but this is equal to this. The idea that you suppose at the beginning. Cool? Cool? Mathematical induction. Sergio Medina dice, cool, mathematical induction, guy. Okay, because in the time that we have, I want to explain at least the principle. I promise that we continue next time in the binomial theorem. This is the last section. Binomial theorem. And this is important in Cal 1. You need to know that. Okay. This formula, I want to discuss it now. And next time we are doing example. Was discovered for Newton. Newton was the famous, no mathematician exactly, physics. But Newton discovered with another guy, but separately, the calculus. Because he needed the calculus for the physics, for the problem of the gravitation or something. But Newton discovered this formula. I want to try to prove like that when he has 18 years old. And what is this about? Suppose that we have a plus b to the m power. What is the formula of this? What is the general formula of this? Newton discovered when he was 18 years old. This is the idea. Entonces now, pero how we are doing, how Newton doing? Newton doing by induction. Study particular example one by one, and get the big conclusion. This is induction. Induction is like a detective of FBI. You have, for example, a plus b to the 0 power. Boom. A plus b to the 1 power. Boom. A plus b to the 2nd power. Boom. A plus b to the 3rd power. The problem is we continue more and we generalize the formula for any m. And we're solving problem, complicated problem to the 20, 40, 60. Hello, what the hell? Okay. Entonces, a plus b to the 0 power es obvio que es 1. Es obvio que es 1 because any expression or any number raised to the 0 power always is 1. It's obvious, right? And this one I want to write here. 1. This one I want to write. This one I copy here for the reason that you see now. And this is a plus 1 raised to the 1 power is just a plus 1. It's obvious, right? And this coefficient is 1, and this coefficient is also 1. I copy to 1. This one is this one, and this one is this one. Because I copy this because I want to investigate what is the partner que this coefficient has. Okay, be careful. Remember, sometimes it's useful when you want to discover a partner, you organization in a special way. And you to organize in that way. Suppose that I expand a plus b squared. This is a squared plus 2ab plus b squared. I suppose that you remember that, no? So you don't remember, no problem. Let's do it by hand. A plus b times e squared, you multiply is a squared plus ab again in alphabetical order plus b squared. And when you combine like term here, it's a squared plus twice ab plus b squared. Okay? I suppose you remember this. You don't remember, you remember now. Well, entonces the coefficient is 1, 2, and 1. Do you see? 1, 2, 1 is this. 1, 2, and 1. Everyone follow me so far? Now, so you are doing the cube, it's a little bit long. This is the idea. I need to discover formulas to go fast. Because you multiply a plus b times a plus b times a plus b 3 times. It's possible, it's doable, but it's long. Suppose 40, that's crazy. No. And the answer I anticipate is a cubic plus 3 times a square b plus 3 times ab squared plus b cubed. Here I copy the coefficients. The coefficient is 1, 3, 3, 1. Look, this coefficient is 1, 3, 3, and 1. Do you follow me? Okay, yes. I want to do one more. And after I want to discover what is the formula. So es a plus b to the 4th power is a to the 4th power plus 4a cubed b plus 6a squared b squared plus 4ab cubic plus b4. Well, okay, I copy now the coefficients. The coefficient is 1, 4, 6, 4, and 1. And you form the triangle here. By the way, this is Pascal. Pascal was the guys, well, Newton discovered, but Pascal organized in this way. Pascal triangle. Because I want predict now what happened in the fifth power. And why not in the sixth power? Shui. Okay. Number one, you see in the fourth power we have 1, 2, 3, 4, and 5 turns. In the 3 we have 1, 2, 3, 4. So we have one more. So in the fifth power we anticipate 6 turns. And the first is obvious is A to the 6. And the last is obvious is B to the fifth. It's the power, the same power. You see the pattern? This is 2, 2, 3, 3, 4, 4, 5, 5. So this is B to the 5. But we have, let me see. We have 6 in total. We have 1, 2, 3, and 4 elements here that I need to discover. Okay, this guy is for n equal 1. This guy is for n equal 2. This guy, no, this is 0, sorry. Sorry. This is 1. This is 2. This is 3. And this is 4. I want to predict next case 5. And you see, wow. Look at this is important moment. You see that number come from you adding this and this. 1 plus 2, 3. This number is 3 plus 3. And this happens always. 4 is 3 plus 1. You see? So we can predict the rest. For example, to 5, we start always, this is 3, Aries. This is 1, this is 5, this is 10. 4 plus, this is 10, this is coincidence. This is 5 and this is 1. This is for n equal 5. So now I can't do this term. This term is 5, not 5. 5 what? A4, because A, the exponent decreasing, 4, 3, 2, 1, 0, no A. And B increasing, B. Plus 10, A3, B second. So, let me see, notice that the exponent of the A is going down. 5, 4, 3, 2, 1, 0. And the exponent for the B is going up. 1, 2, 3. So the next guy is with that. Now 10, no? 10. A to the second, B to the third, plus 5 is this 5. Is A to the 1 power, is just A, B to the 4. Boom. Do you see or no? We almost discovered the formula for the Newton. We almost discovered the formula for the Newton. Let's do it one more to make sure that you understand very well this one. To the 6th power. How many terms we have? 7. One more. 1, 2, 3, 4, 5, 6. We have 1, 2, 3. For sure, I know that the first guy is A to the 6th power, and the last guy is B to the 6th power. And we have 5 guys in the middle. 1, 2, 3, 4, and 5. Okay, and the coefficient this guy for n equals 6 is 1, 6, 15, 20, 15, 6, and 1. Okay, ready. We are ready. That is 6 times, okay, this 6. A to the 5th, B. Plus 15 times A to the 4th, B to the 7th. Plus 20 times A to the 3rd, B to the 3rd. It's a coincidence. Because 4 decreasing. and 2 increase. Plus 15 again, and here. A to the second, B to the 4, plus 6 times, guess this guy. A to the 1 is invisible, B to the 5th, plus B to the 6th. Do you understand the idea? Do you understand?
Yes, it's understood, Profe.
But I have more for you. Because look like too long. This is crazy. However, I want to write the formula exactly in Newton, right, when he was 18 years old. Newton said A plus B to the n power is equal to summation. Because it's summation, no? Summation for k equals 0 because you suppose that this always is k0. But the first is k0. And the last is k equal m, k6 to the n power of the one coefficient. I have no idea what is the mathematical idea for this coefficient. No, I am not sure. But I am sure it's a to the n minus k bk. Who is m? No, n is 6, for example, in this example. And k is 0, 1, 2, 3, 4, 5, and 6. Guess n. Now the exponent of the a, guess the first guy in the binomial, is decreasing k, and k vary because k go from 0 to n. Okay, from k equals 0 is am minus 0 and b 0. That is the reason. Okay, we have supposed to get 6. We have a and not b because b to the 0 1. And the last guy is a to m is n minus m and bm. In this specific case is 6 a 6 minus 6 and b to the 6. 6 minus 6 is 0. So that is the reason that we have no a and we have b6. Makes sense, right? Makes sense? Don't worry for this. I want to practice a lot of these. I want to derivate the formula. That's my intention now. Away to finish the lecture for today. The coefficient of A to this formula is nk. This is a symbolic way to represent combinatory number, que is the same thing that we study in probability. So you need to take a statistic, and the part of the probability we study the combinatory number. But I want to anticipate a little bit. Look, the formula is n factorial divided by k factorial multiplication by n minus k factorial. Let me explain factorial. Factorial is suppose 3 factorial, guys, is 3 times 2 times 1 is 6. 4 factorial is 4 times 3 times 2 times 1. This is 24, right? 12 times 2, 24, and so on. And combinatory number, for example, let's do it in this number. Or this number, okay, I like it, 20. Hey, noise. Who make a noise? Who make a noise? Ryan, you make a noise. No more noise, right? Okay. Suppose I want to find this number, but I'm not using this Pascal triangle because it's too long. No, it's not long, but suppose that we are working with the exponent 45. I said we need to do a big, super big triangle, not good. Now, suppose I want to find, and this is a combinatory number. Look, combinatory number 6. So we are working in the last version. N is 6, but K is 3. Because in the position 0, 1, 2, 3. Keep in mind, K start always in 0. So in the position number 4, K is 3. Because in the position number 1, K is 0. So we have 6 factorial divided by 3 factorial multiplication by 6 minus 3 factorial. Entonces I expand 6 factorial like a 6 times 5 times 4 times 3 factorial and leave like that. Because I know okay, 3 factorial in the top and 3 factorial in the bottom, this one is gone. And stay alive 6 minus 3 is 3 factorial. And 3 factorial is 3 times 2 times 1. Okay, now we have 30, your multiplication now, calculator. 30, 30, 30, 30. This is 30 and 4 is 120. Divided by 6 is 20. Exactly. However, the majority of calculators have a special function to compute the combinatory number. I want to show you next class, okay, in detail. Cool? No problema. You follow me? Okay, too much for today. Okay, have a nice afternoon. And we're connecting Wednesday with a little bit more example of the binomial theorem, and we start review branch. Okay, cool. Thank you.